This section deals with synthetic division. Recall, when you divide anything, your divisor, or what you're dividing by, goes on the outside. The dividend, what you're dividing into, goes on the inside, and then whatever you get as a result is called your quotient. So the divisor is what you divide by, the dividend is what you divide into, and the quotient is your answer. So let's take a look at synthetic division. And synthetic division is a way of dividing polynomials where we don't have to do something like this, which is long division. So again, synthetic division, it's a condensed way to divide. The only thing is that in order to use synthetic division, we have to be in the format x minus c, and where c is a number. Now, notice I have x minus c. The thing here is that it has to have a coefficient of 1. X must have a coefficient of 1 in order to do synthetic division. So, how do you do synthetic division? Well, the very first thing you need to do is figure out what's your divisor. Now your divisor is going to be the number that's opposite with x. So x minus c, your divisor is c. If you have x plus c, your divisor would be negative c. So it's always going to be the number opposite with x. Then you're going to make this upside down division bar, and you're going to put the divisor on the outside left, and the coefficients of your dividend are going to go on the top row of this division bar. Be sure to account for any missing terms. This is really a big deal here. Now, what does that mean? Well, if your dividend's highest power, so if it's a degree of 5, then you need to have a coefficient for the 5th degree, the 4th, the 3rd, the 2nd, the 1st, and a constant term. If one of those terms doesn't exist, we just put in a 0 placeholder. And we'll get to some examples where we do that. Once all those terms are in, we bring down our first coefficient, then we multiply the divisor by that, put the product in the next line over, add down, and then you keep doing all these steps that it said right here until you get to the very last column, until you run out of columns. Well, no, the numbers that we get down here, those are going to be the answer to our division problem. That's the quotient. And if you're putting it back into a polynomial form, it's going to begin with 1 degree less than your dividend. And the reason for that is we're dividing by a linear term, so it's always going to be 1 degree less than our dividend. Let's take a look at some examples of doing this. Example 1. Perform the indicated synthetic division. Step 1. Determine what your divisor is. The divisor is always going to be the number opposite with x. And remember, if you're taking a look at this division, this is this number divided by that number. So automatically, this is my dividend, and this is my divisor. The divisor, I just need a number. The number opposite with x, my divisor is going to be negative 1. I'm going to call it c because we've been calling it c. So c is negative 1. Alright, then it says, alright, make this upside down division bar, place the divisor on the left, on the outside. So I'm making an upside down division bar, and I place the negative 1 left on the outside. Then it says to place the coefficients of the dividend on the inside. Make sure to account for any missing terms. So squared, first power, constant term, there's nothing missing. So let's place those coefficients on the inside top row, which is 3, 5, and 2. Again, just the coefficients, not the x's. Then it says bring down the first number in the dividend. So we bring down our first number. Right? Now we multiply the divisor and the number we just brought down. So the divisor and the number we just brought down. If I multiply negative 1 times 3, I get negative 3. And it says place that product under the next coefficient in the dividend. So negative 1 times 3 is negative 3. And I'm supposed to place that product under the next coefficient in the dividend. So that would be the next coefficient after this one. Add down. 5 plus a negative 3 is a positive 2. Now we repeat all the steps until we run out of columns. So go back to 4, multiply the divisor and the number we just brought down. Negative 1 times 2, negative 2. Next step says add down. 2 plus a negative 2 is 0. I stop because I've run out of columns. There's no more columns here to worry with. Alright, great. So then the answer for the division is going to begin with 1 degree less than the dividend, and these numbers down here are the coefficients of the quotient. Alright, well, what does that mean? And I'm just going to rewrite this because I've written all over it. Well, it means that 3x squared plus 5x plus 2 over x plus 1, when you divide that, it is equal to 3, and then 1 degree less than squared is just x, and then since this is a positive 2, plus 2. Now notice linear term, first power, and then constant term, and then I have a remainder of 0, where this last number is my remainder of 0, and I don't ever write that. But 3x squared plus 5x plus 2 divided by x plus 1 is equal to this 3x plus 2. Alright, let's look at example 2. Really, the more you do these, the easier they get. So we have 3x squared plus 5, and we're dividing by x minus 1. The very first thing that we're going to need to do is determine our divisor. Okay, remember this is your dividend, this is your divisor. The divisor is going to be the number opposite with x, so we have a negative 1. So my divisor is a positive 1. Make that upside down division bar. Write the divisor on the outside left. Then write the coefficients of the dividend on the inside. Now remember, we have to count for all terms. So this is to the second degree, so I need a term for the second degree, or an x squared, and then I'm going to need a linear term, and then I'm going to need my constant. Well, 3 is the coefficient of my x squared. Do I have a linear term? Is there an x term in this? No, so I just write a 0 placeholder, and there's my constant. So again, any time you're missing a term, you just write in a 0 placeholder. So we got all that done. Then it says, first step, bring down the first number. Then multiply divisor times the number I brought down. The product of that, 1 times 3 is 3. Write it, next column over. Add down, 0 plus 3, 3. Multiply, 1 times the number I just brought down of 3 is 3. Write that product, 1 column over. Add down, I get 8. I've run out of columns, so I know to stop. Well, what is this polynomial? Well, this polynomial is, remember, it starts 1 degree less than the square, 3x. This is positive, so plus 3, and this is positive, so we're going to say plus, and this is my remainder, so we're going to say 3 over x minus 1. Because it's a remainder, it's 3 over the divisor. So 3 over the divisor. And we're going to write something down that I'm going to erase, just in case you're kind of curious why we did this. Let's say that we're just dividing 2 into 5. If I divide 2 into 5, I say, well, it goes twice, and it has a remainder of 1. So before, we could say that it's the quotient, and then it's the remainder over, plus the remainder over the divisor. So we've always been doing it where we have quotient and then plus the remainder over the divisor. Just maybe haven't done that in a long time. So again, if there's a remainder, if this number isn't 0, you're going to need to write that number, which should have been an 8 and not a 3. So you need to write that number over x minus 1, which is my divisor for this problem. Alright, let's look at the next problem. First step, determine your divisor. Opposite the number with x, so c is going to equal negative 5. Make your upside down division bar, put the divisor on the outside, put the coefficients of the dividend on the inside, make sure to account for any missing terms. Third power, second power, first power, constant. I don't have any missing terms. So let's write the coefficients. We got 1, positive 4, negative 5, negative 9. Bring down that first term. Negative 5 times 1 is a negative 5. Write the product, next column over. Add down. 4 plus a negative 5, negative 1. Negative 5 times a negative 1 is a positive 5. Write that product, next column over. Add down. Negative 5 plus a positive 5, 0. Negative 5 times 0, 0. Write that in the next column over. Add down. Negative 9 plus 0, negative 9. So, what is the quotient? What is the answer here when I divide x cubed plus 4x squared minus 5x minus 9 by x plus 5? Well, it's going to equal 1 degree less. If this is a cube, I start with a squared. 1x squared, or just x squared, minus 1x, or just minus x. I don't have a constant term, so I don't really need to write plus 0, because we don't really do that. But I do have a remainder. My remainder is a negative 9, so I write minus the remainder of 9 over the divisor of x plus 5. So the quotient, or the answer when you divide those two polynomials, is x squared minus x minus 9 over x plus 5. Last one of these before we get to something different. Again, first thing, figure out your divisor, opposite number with x, c is -2. Right, mix an upside down division bar, put the divisor on the outside left, the coefficients of your quotient on the top. So I have a fourth power, so I need again fourth power, third power, second power, first power, and my constant term. Do I have all those? Nope, I just have a fourth power and a constant term. So coefficient of the fourth power is 1 because there's no number in front of x. For all the missing terms, I put my 0 placeholder. Constant term is 32. Bring down the first number. -2 times 1 is -2. Write the product next column over. Add down. 0 plus a -2 is a -2. Multiply -2 with the number you just brought down of -2, +4. Next column over. Add down. 0 plus 4 is 4. Again, -2 with the number you just brought down is -8. Write it next column over, add down, 0 plus a -8, -8. Multiply again, -2 times a -8 is a +16. Next column over, add down, and we end up getting +48. Run out of columns, so I know to stop. So what is the quotient? What is the answer here? Well, our answer is going to equal, remember it starts with 1 degree less, so 1x cubed, or just x cubed, minus 2x squared, minus 2x squared, plus 4x, minus 8, constant term, and then here's my remainder, and that's going to be plus, because it's positive, 48 over my divisor of x plus 2. Alright, the second part of this video deals with determining whether or not we're a factor by using synthetic division.